Morning, everybody. Today we're going to talk about the oceans. Here's my ocean. All right, we have been talking about how airflow, the uneven heating of the airflow over land, is what brings us our weather. So the fact that the air even moves is due to the uneven heating of air, and that this is what brings us weather or drives our weather patterns. However, only about 1/4 of our planet is land. Most of our planet is water. About 3/4. So most of the planet is water. And I would like you guys to think about how does heat transfer how does the heat transfer over water, so the heat transfer with water, affect our global and local weather? And I'm going to discuss today about why heat transfer over water is different than over land. A term that I would like to also have for you guys to have in the back of your brains is climate. You've all heard the terms climate change and global warming. And are they the same thing? They are used interchangeably, but what is climate? Climate is the long-term average. So it's the long-term average temperature. Oh, sorry, average weather. Um, so climate is the long-term average of weather conditions in an area. So we would say here in New England, our climate in the summertime is mostly warm and sunny. And you might say the climate in Alaska is pretty cold, and in the wintertime that they get lots of snow. So the climate for the whole planet is the long-term average. The climate for where you live, we are talking about all of your weather over a very long period of time. All right. When we are talking about global warming, we are talking about the climate of the planet changing so that it is overall warmer. you can see climate change is in the definition for global warming. But climate change could also mean that it's going to be drier, or that it's going to be wetter, or that it's going to be colder. Where global warming is specifically talking about the whole planet warming up. I'm going to talk to you guys today about how ocean temperature affects the weather. I will give you a lesson on Monday about climate change and global warming, and then we are going to start the next unit on simple machines. So I asked you guys to think about how does heat transfer affect the global and local temperature over water. And in order to do that, I have to ask another question. I have to ask, how much energy? So how much heat does it take? How much heat is required to warm water 1 degrees Celsius? And we're actually talking about heating 1 gram of H2O 1 degrees Celsius. So we're just taking 1 gram of water and we're going to make it be 1 degrees Celsius warmer. This has a special name and it's called the specific heat. And all substances, they figured it out for pretty much every substance. How much energy does it take to heat anything? 1 gram of anything, 1 degree Celsius. Well, you know that they looked at water first because water is so important for us. So it takes about 4.2 joules of energy to heat 1 gram of water 1 degrees Celsius. What does that mean in the grand scheme of things? This means that it takes a lot of energy. And that water can absorb, a lot of heat before it changes temperature. So it absorbs a lot of heat before it changes its temperature. So we say that water has a very high specific heat. For comparison, it only takes about 4.75 joules to heat 1 gram of a brick 1 degrees Celsius. So not a whole lot of energy here. So bricks, the red bricks, require less, much less. So it takes a lot of energy to heat up our water. What does this mean for heat transfer? Basically means that air that sits over land will heat up much faster than air over water. And what happens when that happens? Well, here's my land. Here's my little flowers. Here's my ocean. So it takes a lot of energy to heat this up. My flowers. All right. Here's my sun. So as the sun is sending out its heat energy to the water and to the air over the land, the air on the land heats up faster. We said that's low pressure, warm air rises, and it creates updrafts. The air over the water, which is more dense, high pressure, then moves to fill this space. That makes the air over the land move out over the water. This creates downdrafts over the water. As the cool air sinks. Does that look like something that we have been talking about a lot? Here's my cool air moving in to take the place of the warm air. Here's my warm air moving to take the place of the cool air. So again, convection currents get set up. Yeah, we're talking about convection currents again. What does this look like on a global scale? Some things we are going to be looking at. So just like with the air currents moving in different directions based on how they are heated, here is a map of the oceans of the world. And the water along the equator gets heated first. And we will be talking about how heat affects water density. And it sets up these currents. So the warmer air that is along the equator begins to move northward or southward, and the cooler water, and the cooler water that is at the poles begins to move in to take the place of the warmer water that has moved northward or southward. And what ends up happening is we have a giant basically like a giant conveyor belt of water movement through all of the oceans over the whole entire planet. So when I showed you the picture of the Earth with the winds moving in different directions, it is the same thing that is happening with our bodies of water. So I'm going to include both of these pictures on the Google Classroom page. Just like the wind, how temperature and the spinning of the earth affect what direction the wind is going in, the same is true for water. In that both temperature and density affect how the water is moved. So, water closest to the equator heats up first. Let me give myself a pen. We'll do it. Put that over there. I'll do it right here next to the map. So water closest to the equator heats up first. It begins to move towards the, oh, there's an S in there. It moves towards the poles. The colder water begins to move in to take the place. So the cooler but it's not just temperature that affects how the ocean moves, but it's how dense that water is or how heavy it is. So the water's density also affects movement. We said density is how heavy it is. In the case of air, it's how much water is in the air. In the case of the ocean water, it is affected by temperature. So cooler temperatures mean more dense. Cooler temperatures mean more dense. Warmer temperatures mean less dense. And salt. Salt content. So that's called salinity. 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 So higher salinity is more dense. Lower salt content or salinity is less dense. Just like with air, as it is moving upwards through the volume of the atmosphere, the same is true about water and as it is moving through the volume of the ocean from the surface to the bottom. So right here I have a picture that I will be including on Google Classroom for you guys. And this picture is going to show you the temperature of the surface of the ocean from 0 feet down to 600 feet. This is in the Pacific Ocean. Here's North America. Down here is the tip of South America. Sorry, part of South America. And it is showing you surface temperature. The ocean surface is considered to be down about 600 to 800 feet. So surface temperature. For us, we would consider the surface like how deep we're in it, but for the ocean, surface temperature is goes down 600 to 800 feet is considered surface temperature still. I want to show you this first picture. Just south of what this picture is the equator. So, and as you would imagine, the water closest to the equator is hot and the heat goes quite deep. So temperature goes down to about 500 feet probably. The warm temperature is here in red, and then the cooler temperatures are shown in the blues, and green it becomes slightly cooler. In the wintertime, this is what it looks like, and then in the summertime, this is what the temperature looks like. The winds are moving in this direction, east to west, and they push this warm blob of water outwards in this direction towards the continents. What happens here? So I've already talked about how water takes a lot of energy in order to heat it up. And once it's heated up, then evaporation occurs and our water molecules go up into the air, and that's how we get clouds, and it drives our water cycle. So let's imagine that the water is already warm. So if that water is warm, warmer surface water, means that it's going to take less energy to start the water cycle going. So for us, or in general, warmer surface water means wetter and more severe weather. For other parts of the world. This is actually an actual image of January and June of 1997, and this is an El Nino event. So when we are having an El Nino event, we have warmer winters here in New England. Heavier rains in California. When we have a normal winter, this is what a normal winter would look like. They call that La Nina. Um, La Nina has cooler surface water temperatures. And we have a more normal winter. Right now, the El Nino La Nina weather cycle that occurs off the coast of Chile, it goes in about a 2 to 7 year cycle. As that water moves, it gives off some of its latent heat. So as the water is moving, it carries its heat with it. This is its latent heat. And so this is why some of our currents, like the Gulf Stream, carries heat from the equator to places like Iceland and Great Britain, making them warmer than they would otherwise be. Oh, sorry. So if we go back to this map right here, here's the Gulf Stream. The warm water moves like this, and part of it carries warmer water here to Iceland, making it be habitable, and to Northern Europe, making them have more mild temperatures than Norway and Sweden and Finland, who are just that little bit further north and don't get the benefit of that warmer water right here. So as you guys can see, the uneven heating of the whole planet, both the air and the water, affects our weather. And it's not just the heating on the surface, but it is the heating of the whole volume from the surface down, or in the case of air, from the surface moving upwards. So I guess that's all that I have to say about the oceans. On Monday, I'm going to talk just a little bit about climate and climate change that we are experiencing. And then on Tuesday, I will start the simple machines.